Okay, today we are going to use the Frayer method to talk about Newton's third law and the normal force, which are related. We're going to start out and talk about the definition. And when you do it at your desk with the organizer, I want you to use your own words. I'm going to describe it in the words that we use from the textbook and how most people explain it. But I want you to explain it in a way that works for you. So the first part is Newton's third law says that every action or force has an equal and opposite reaction. And so one simple action or force. One simple way to say it would be if you foolishly kicked the wall, the force that you applied to the wall would be applied back to you on your foot, which is why your foot would hurt. This is kind of explaining that there's no force. You can't apply a force without it coming back in a way. So that's the first way of explaining it. And you can think about how that works for you when you describe it on your sheet. And the normal force is one way of describing that force that comes back. If you'll remember, we previously talked about balanced forces and how if forces are balanced, nothing moves. When we talked about Newton's first and second laws, if we have a table and on that table we have a bowling ball on top of the table. Okay. We know that gravity is a force on that bowling ball. We also have a normal force. Let's use great for that as well. And that force is the way we describe the fact that the bowling ball doesn't go through the table. The table provides the equal force to gravity, and that's why it's called the normal force. But it also corresponds to Newton's third law. So this force of gravity has an equal and opposite force, and that's the normal force. Okay? So if we take a look at the main characteristics of this, and this might help you write the definition in your own words, but the key characteristics we have are these are balanced forces. Okay, they have the same amount of force or the same magnitude. Okay, same amount, same magnitude. It'd be like if you have any sort of things that are, sometimes people would explain that if you watched American football and in the beginning of a play, the players push against each other. If they don't move anywhere, they have balanced forces. Balanced forces don't, the object with balanced forces won't move. So the other thing to know is that these are equal, which is the same as balanced, and they're opposite. which means that these forces always operate opposite each other. Because if they were equal and opposite, if they were equal but not opposite, then you would have some movement in one direction or another. Okay, so those are the important characteristics to know about Newton's third law and the normal force. The normal force is always going to be equal and opposite of gravity, or possibly some other forces. But in this case, typically gravity is the force that we're concerned with when we talk about the normal force. So if we want to talk about some examples of Newton's third law, or the normal force, we have the one that we already drawn here, the bowling ball on the table. If we want to talk about some of Newton's third law, we can draw a balloon, and if this balloon has air coming out of it, we know that the air escaping has a force going down, and we know that the balloon has the equal and opposite force, and it goes in that direction. Okay. Another example we could use is if we have a cannon, like everyone does in their backyard or somewhere else, maybe, I don't know. And it's on a set of wheels here. As the cannonball gets shot out, it applies a force to the cannonball in this direction. But the cannonball exerts a force on the cannon, and it will roll this opposite direction. So we've got that. One that might be a little bit more applicable to those who don't have a cannon in their backyard. If we draw a shoreline and a boat in some water here. Okay. And we have a person on this boat. If they step out, that's their action. The reaction would be the boat will move the opposite direction. Maybe some of you have been in a situation on a canoe or a different boat somewhere when they went fishing or something. And if you step off the boat will go the opposite direction that you stepped. So those are some examples of Newton's third law. Hopefully those will help you put the definition in your own words. And as we talk about Newton's laws, let's go back and think about some non-examples, things that aren't Newton's third law, but might get confused with Newton's third law because we have the first and the second to think about. So if we think about Newton's first law, we can think about a car, maybe it's SUV, and it is driving this way, to my right, probably your left, and it has a box on the top of it. I don't know how the box got there, but I just know it's up there. And it is driving down the road. If this SUV stops, that box, what do we know is going to happen to it? It's going to fly off. So let's say that this SUV stopped for a cone in the road. And the box is going to go flying. Okay. So that was Newton's first, which we call inertia. We already talked about that. Okay. So this is not Newton's third. Okay. And then if we talk about Newton's second, we have a person, and this person is playing soccer. What does a soccer ball look like? It has shapes like this. Okay. So this is the soccer ball. And we'll remember that the second is characterized by the equation force equals mass times acceleration. So we have that person playing soccer, and then we have this person down here is the person who got off this boat here, and they have a beach ball. We know, based on this equation, because the mass of these is different, the force required to move each of them is different. So it will take more to make the soccer ball move than it will to make the beach ball move. So that's our example of the second. Neither of these represents Newton's third, which is this action-reaction that we want to think about in today's lesson. Is Newton's third law, the action-reaction, the equal and opposite. And we can think about the normal force and how it relates to it based on it being on a table. And that is our initial Frayer method to think about Newton's third law and the normal force. Thank you.